Azure Resource Graph is perfect at three things: exploring resources, drilling down to gain deeper insights, and analyzing resources and their relationships. It allows you to interactively refine your results. For example, focusing on a specific subscription or viewing resources across all subscriptions. You can also access all your resources at once without limitations. It's important to understand that Azure Resource Graph's query language is based on the custom query language used by Azure Data Explorer. The language for the Azure Resource Graph supports a number of operators and functions, and Azure CLI supports Azure Resource Graph through an extension, while Azure PowerShell supports it through a module. Before running any queries, make sure your environment is ready by enabling the extensions. The count operator returns the number of records in the input record set. This query returns the number of Azure resources that exist in the subscriptions that you have access to. It's also a good query to validate that your shell of choice has the appropriate Azure Resource Graph components installed and in working order. The project operator is used to select the columns to include, rename or drop, and inserts new computed columns. The order of the columns in the result is specified by the order of the arguments. Only the columns specified in the arguments are included in the result. Any others in the input are dropped. In this example, the columns are name, type, and location. It uses the operator order by to sort the properties by the name property in ascending order. Again, in this example, we make use of the order by operator to show all virtual machines ordered by name, but in descending order. The top operator performs similarly to the limit operator. In this example, we are limiting the output to the top 5 virtual machines. Now let's run some of these queries against some of the resources I created earlier. So I have a bunch of different resources, and each of these resources is within 3 different subscriptions. Using Azure Resource Graph, I will demonstrate how you can efficiently explore at scale across a given set of subscriptions so you can effectively govern your environment. For this exercise, I will run my Azure Resource Graph queries using the Azure command line interface. You could as well use PowerShell or by using the custom query language used by Azure Data Explorer. To enable Azure command line interface to query Azure Resource Graph, the extension must be added. So we've succeeded in installing the Resource Graph extension. You can also validate that the extension has been installed and is the expected version, which must be at least version 0.1.7. To do that, I'll use the easy extension list command. Our version is 0.1.8, which is appropriate for Azure Resource Graph. So we can run a simple query against our subscriptions with different options and different arguments which display certain aspects of our objects in our subscriptions. With the Azure command line extension added to my environment of choice, it's time to try out a simple resource graph query. The query will return the first 5 Azure resources with the name and resource type of each resource. So the command is Azure Graph query. This queue, use the project operator. I want to list the name and type and limit it to the top 5. So this query has returned the first 5 Azure resources, which is our virtual network, network security group, a public IP, network interfaces, and a network watcher group. The count query returns the number of Azure resources that exist in the subscriptions that you have access to. It's also a good query to validate that your shell of choice, in my case Azure Command Line interface, has the appropriate Azure Resource Graph components installed and in working order. This query tells me what operating system my compute or virtual machine is using. In this case, the virtual machine name is Enterprise Resource Management 1, the first instance of my Enterprise Resource Management application server, and it is running on Linux. The Microsoft Azure documentation website gives you different sample queries you can use for resource exploration. For a start, you could look at what shell or what environment you are using. I was using Azure Command Line interface, so here it shows you how to import Azure Resource Graph into that environment and how to validate it, and also queries you could run just to start using the Azure Resource Graph. For those who prefer PowerShell, you also have different queries to start Azure Resource Graph and to validate that the module has been imported and it's a correct version. Once you have installed the module, you could look at starter queries, which walk you through different types of queries. For example, how to count Azure resources, list resources by name, show distinct values for a specific alias. You could copy the various commands into your environment and you observe what information each of them displays. There's also advanced queries you can use: get virtual machine scale, set capacity and size, list all tag names, virtual machines matched by regular expressions. The list is endless, and Resource Graph only supports a very small part of the operations that the Coastal query language supports. To summarize, in this lecture, we've looked at Azure Resource Graph, which is a service in Azure that is designed to extend Azure Resource Management by providing efficient and performant resource exploration. It allows us or gives us the ability to query resources with complex filtering, grouping, and sorting by resource properties, as well as to iteratively explore resources based on governance requirements and to assess the impact of applying those policies in a vast cloud environment. It also gives us the ability to detail changes made to resource properties. And we said most change is by design, but sometimes it isn't. With the last 14 days of change history, Azure Resource Graph enables you to find when changes were detected on an Azure Resource Manager property and to see what properties changed as part of that event change. In our next lecture, we're going to take a look at Azure Blueprints, which enable quick, repeatable creation of fully governed environments. It allows us to easily deploy resource templates, policies, and access control so that our environments are ready to start being used straight away. It enables compliant development. That is, you can speed deployment of compliant applications to production through a self-service model. You can also limit access to key infrastructure that's shared across subscriptions to prevent unwanted changes.